So we're back to the gritty version of this. So first of all, when we're given the original setup, we're given this as, frankly, our P portion of the statement and the Q version, Q portion, is that they're even. Then we have our result, both X and Y are even. So again, this is our X times Y, this is our X plus Y, both of them end up being even, therefore both X and Y are even. So that's the original setup. Now we talked about this already, that this original setup won't give us enough when it comes to cases. So what we're going to do, we're going to apply contrapositive in order to do this. And remember, contrapositive means that we flip and negate. So that's why R is now over here. That the physical, think of this as one variable here. We would negate this part and that part, and we flip the two. That's positioning-wise for contrapositive. So now that's why we have this. Now, we do De Morgan's to go ahead and kind of break this up to get rid of the parentheses. That's why the gates change it. Now this is an OR, so heads up from that. And both of these have negations in front of them. So not R, but show that either negated P or negated Q is true. And that's the important part, is negated P or negated true. So this is actually should be pretty easy to solve, but again, it's going to give us more cases that you're going to see down the way here in a moment. So P originally was X times Y is even. Now it's, well, X times Y is odd. Now, by the way, notice he keeps it a very simple statement. There's no ors or ands or anything else like that was in the original problem, because that takes care of this now. And the either part takes care of that, and that's on the table down below. And the same thing with the Q. All right, manual labor. Now it's the manual labor time. Now, here is our chart that you, well, frankly, probably would think of as being cases. And yes, each one of these is a case, where true is that the values of X and Y are false. So there's our true, 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 false. Now remember, here's the interesting part about this. Because we've done contrapositive, it's not both anymore. It's either or for both of them. So it could be either or one of the two. Now here's the funny part is, this last one, even though I did all the work still, that's actually, I don't need that, because frankly, it doesn't say both are odd. It just has to be one or the other. So this last one is very, well, it's the opposite of the previous one we did when we did just cases. It was just one case. Now it's taken out. So here you have our overall solutions for this. Here's our negated P, here's our negated Q, and this is very simple math. I'm multiplying X times Y, and the check marks are showing us where things were odd. Now again, because we're using the OR, I only needed one of them to have an odd to show that this is actually ends up to be true. So that part looks great, all right? Well, here comes our WLOG. As we look at our data, we actually have two rows that are very similar, right? That came out with the same type of outcome. That's a problem. We don't want to do extra work, right? So when we have our WLOGger without loss of generality, got that right finally, what we can do is we can actually scrunch a couple of things together that frankly have the same output. Now, there's one way of doing this where, frankly, in the book, what they're going to do is they're going to share that they're going to focus on these two things, because this one, notice I'm going to put, not really fading it out here, but it looks the same. Now I have two columns that are slightly different. Okay, we eliminated one because there's no way it's a possibility. We eliminated another one because, frankly, it has a lot of duplication in what the overall result would be. So we're really down to two cases. Now, the WLOG part really isn't this part yet. It's actually this part. Notice that everything that we've weeded out so far, one item that both possible conditions actually share is that both of these have X that is an odd. So that's what you're going to start seeing when we get to the actual documentation of what is our conclusion. Using without loss of generality, we're going to say that we can assume that X is odd, and then we have to do our mathematical write-up on exactly how this sets up in order for you to be true. By the way, I only needed one of these to be true for each case. In the first case, it took us one item, or the first item of x times y to find it's true. I'm still going to show you the other side. For the second case, I'm going to show you the first one didn't work out. It did work out for the second one. So now is the write-up that we've got to do in order to basically complete this and complete our conclusion. Now we do the formalization of the proof. I go by the cases. The cases I did in that table, but now I really kind of have to show it, frankly, well, as a proof and written up. So you'll see two different cases, so be careful. There's case one where y is equal to odd, and that's why I put that equation there, y equals 2n plus 1. And the other case is where y is even and y equals 2n. Now, where the heck did x go? Well, remember with our without loss of generality, we already assumed that x is going to be odd. So every time that you see x in any of these equations, you'll notice it's 2n plus 1, which means it's odd. So that's a nice little catch that we have with our WLOG or anyway. So in case number one, notice that you have two separate items that I need to test, which is x times y and then x plus y. I need to do that for every single case, but again, my overall conditions are a little bit different for each one. As soon as I find that one of them's odd, I can actually move on, like I did in case one, x times y, doing our math manipulation, and then our substitution, I'll be darned, I got the form of it being odd. So we have odd. I really wouldn't have to do the rest of it, but I wanted to show you the work anyway. As soon as I get my odd, for case number one, I need to jump over to case number two. In case number two, it actually took me 2 tries to find the odd. First was the x times y, and it ended up just to be true. Sorry, not true, but even. And then the second one ended up to be odd. So in both cases, I've got my check marks for both of the cases. Then we're in good shape. And then I can do my conclusion, which frankly is a copy and paste really of the original proof. But at the end, it says using a proof by contraposition and cases. And the order does matter. Just because we did contraposition first, and then we got to the cases. That's really important, and we explained why we had to do that, just to hit a lot of different terms in this. So yes, a very convoluted example just to get a lot of different things that are terminology and items that are used in proofs. Hope you enjoyed it though.